All right, so we're going to graph some lines again, but this is going to be a little different. I don't know. It doesn't matter if you did it in Algebra 1 or not. I'm going to teach it to you anyway. But this is something that you may or may not have done in Algebra 1. I know you graph straight lines, so I would think a rigorous Algebra 1 class would include this. But if they didn't, no big deal. We're going to do it now. All right, so example 1. We're going to graph an inequality. So let's start with this. All right, so we're going to graph this. Instead of x minus y equals -2, we're going to put greater than or equal to -2. They do it two different ways. Well, actually, they do it one way in the book. They do it with x and y intercepts. To tell you the truth, at this point, I don't care whether you do it with x and y intercepts or not. If it was me and I was just asked, to graph this, I'd probably put it in slope-intercept form. All right. Now it is an inequality, but I'd still get y by itself. That's what I would do. All right. So let's do it that way. Let's keep the minus y right there where it is. Let's get rid of the x. Do you remember the rules for inequalities? Have we done inequalities yet this year? We did? Okay, so we talked about changing the sign or the direction of the inequality. All right. Yeah, so that shouldn't be a big deal then. Right, everybody good with that? We don't change the inequality because all I did was subtract something from both sides, so nothing changes. What's that? When you divide, not just division, but by a negative. That's when you change the... And we have to do that, though, don't we? We have to divide by a -1. So we will change the direction of that inequality. All right? So it's less than or equal to what? Positive x, what? Plus 2. All right? Let me just grab this. All right, guys. Hey, Chandler, face front. Don't worry about it. No, don't say anything. So here we go. Let's graph this as if there was no inequality, because it does say greater, or it does say or equal to. You remember the difference? If it says or equal to, you draw a line a certain way. Yeah. Remember that? No. So what? The dash in the straight line. Okay, so if this is or equal to, what kind of line is it? It's a solid line. Okay, if it's just or equal to, it's a solid line. If it just said less than or greater than, it's a what? It's a dotted line. Okay, but it is or equal to, so we are going to use a solid line. So let's graph it like we would graph any straight line, a linear equation. Okay, y-intercept is 2. The slope is 1. Rise 1, run 1, or you could. Once I do one, especially when the slope is 1, right, I put a whole bunch of points in there just to make sure my line is straight the way it's supposed to be. Oops. There we go. Oops. All right. So are we done? That's our line and we're good? No, because of this thing right here. So we want to find all the values, listen. We want to find all the values for x that's going to make y less than or equal to x plus 2. All right? There's a couple ways you can do it. I'm going to show you, I don't know if it's not an old-fashioned way, but there's a way to do it. What I'm going to do, Gio, you paying attention? I think you're worried about something else. You're just making jokes. Get your feet off the desk. There you go. There you go. Now you look like... You'll halfway look like a student now, okay? Or an honors student. So, watch what we're going to do. I want to find what are all the values for x that's going to make it's going to make y less than x plus 2. So here's what we could possibly do. You could choose a point anywhere, above or below. Don't pick one like super, super close. Pick one that's an obvious point that's either below the line or above the line. Let's plug it in and see if it works. So you could go 5, 5. Well, do you? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, you could pick that. That's fine. Okay. What's a super easy point to pick? 0, 0, definitely. Okay. You don't have to. You could pick any point below this line or above this line. It doesn't matter, okay? So I would pick something super easy. 0, 0 is obviously, I think, the easiest one. So let's put it in here. 0, let's see if it's less than or equal to what? 0 plus 2. So is the number 0 less than or equal to 2? Absolutely. So is that a valid point? Yes, it is. I could pick a whole bunch of points if I wanted to, but I can pick any point below that red line, any single point below the red line, and it's going to satisfy this inequality. It's going to make it work. Let's just for fun pick a point above the red line. Let's go 0, 3. That would be a good one. 1, 2, 3, or we could go, Geo really loves the 5, so we'll go 0, 5. 1, 2, 3, 4, 5. Let's pick this point right here. That's absolutely 100% above that red line. Would you agree? So let's see if that works. So what is it again? It's 0, 5. So what's the y? It's 5, correct? Less than or equal to what? 5 plus 2. Is that true? Is 5 less than or equal to 7? Is it? Question mark? Is it? Wait a minute. What did I do? It should be a 0. It should. It's because, no. It's the other way. This should be a 0. My bad. I was going to say, this does not work, or it does work, and it's not supposed to work. All right. So let's try this again. Is 5, is 5 less than or equal to 2? Question mark. No, that's not true. So that means any point above the red line will not satisfy this inequality, okay? It won't make the inequality work. But any line where? Or any point, I'm sorry, below the line, okay, does make it work. You could try. I mean, try that point right there. It will work. It'll make this thing right here work. You follow me? You can pick any point over here. So how do I show all these points? You shade it in. Exactly right. So won't be the prettiest shading, but have we done that? We haven't done this, have we? In here? Last year, yeah. Oh, we did in geometry? We did?
No, we didn't.
I think you did it in Algebra 1. Yeah, it's like I said earlier. We did it in algebra? Or I mean geometry?
Oh, no.
I don't think we did. I don't remember teaching this in geometry.
It was a circle thing, remember?
Yeah, it was a circle. Yeah, but I remember circle.
We did circle shading?
Yeah.
That stuff was hard.
When did we do that? I don't even remember that.
It was like when you had the.
Oh, it's the thing with the sector and stuff.
Yeah.
Oh, wow. We didn't really shade it. It's just kind of, yeah, it was just showing you what part of the circle we were trying to find the area of, right? Okay, I do remember. But we didn't do this, all right? So that would be your graph right there. Now, do you have to shade like every little spot? No. I mean, some people are very particular about it, but this gives you enough. Stop talking when I'm trying to teach, please. All right? The jokes aren't funny, so they're just falling flat. So that's your graph right there. That's how you graph it. The shading's super important because of that inequality, all right? And you can pick any point in that shaded region, and it's going to make this thing work, all right? You get that?
Yeah.
Yeah, easy. Here's another way. You could pick a point, or you could just look at it and say, this says what? Y is what? Less than. So less than would be where? Below the line. That's right. So if it says less than, it's below the line. But it said greater than. But we want to put it in that slope-intercept form, like y equals or y is less than. I don't know if they can really consider it slope-intercept form because of the inequality, but they probably do. All right, we can think of it that way. But yeah, I'm not going to go through and do a point every single time just to see what works. I just know it's everything below the line that's shaded in. We good with that? All right, let's do another one. Two more. Let me copy that. All right, and let's put that here. And we're going to do another one. But it's not just going to be a little, well, it is going to be linear, but I don't know. It's just going to be a little bit different. This is example 2. All right, and here's what they say. They make the notation kind of fancy. This is called graph F. All right. So that's the name of this little equation thing they're going to give us. They put it in that like set notation thing. I think they give it some other crazy name. I don't really care what the name of it is. Do you remember this? So what we're going to do is we're going to graph not just a point. Okay, we're not just putting a point in there. We're putting 2 points in there. We're putting 2 points in there such that, and they give you the equation, 3x minus 4. It's basically the same thing we just finished doing, just a tad more complicated, that's all. Okay? So let's just go through it pretty quick since we've already talked about that. They make it look kind of fancy, but really, does that really change anything as far as our math is concerned? No, it's just what it looks like. Just the packaging, all right? So this right there is what we're going to graph. So let me write it down. It's not an or equal. So what is that going to do to our graph? It's going to make it what? Make it dotted. That's right. So what do we do here? What's our goal? What's our goal? To get y by itself. Okay, so let's get the 3x on the other side. So this is going to be a negative 4y. Subtract the 3x. Keep that inequality the same. Subtraction does not change the inequality. All right, so we keep it a less than. But now we are going to get rid of what? A negative 4. So we will have to change the inequality. If you multiply or divide by a negative, that changes this thing right here. Okay? So it's not less than, it's what? It's greater than, what's this? 3/4 x. What's this? Plus 2. So really, we're just trying to graph this thing right here. All right? Started off looking like that. Just makes more sense that it looks like this. If you wanted, you could have done x and y intercepts, couldn't you? You could have said, to find the x-intercept, set y equal to 0. To find the y-intercept, you set x equal to 0. Again, you could have done it that way, but I don't know. I just kind of like doing it like this. So let's graph the thing. Y-intercept is 2. It's positive 3/4, so you go 1, 2, 3, 1, 2, 3, 4. If you wanted, I like to put one on the other end too, just to make sure my line is nice and straight. So 1, 2, 3, 1, 2, 3, 4. Wouldn't you agree? Yeah, see how it lines up?
Wait, so
That's my slope. Oops, I don't want to. I think there's a way I got to figure out how to do this, but I'm not going to do it because with this other program I use, I know how to make it a dotted line. Does this thing make it dotted? I don't think it does. Is there? No, that doesn't. Yeah, so it is. Yeah, so what we just did, we counted 3 over 4. All right, so there's your. That's good. It's good enough. Now, what's it say? It says y is what? It's greater than. Where are we shading on this one? Right, we're going to just shade above it. Now, if you wanted to, you could pick a point, put it in there, see if it works. Let's just do it for fun. Let's do 0, 0 again. So 0, let's check to see if it's greater than, what's that? 3/4 times 0 is 0 plus 2. Is 0 greater than 2? Nope. So we are not going to shade down here where the 0, 0 is. We're going to shade in the other region. So we're going to shade up here. So any point in that area that I'm shading in, any point in there will satisfy this right here. Any point below it will not satisfy. We already tried 1, 0, 0. It didn't work. None of the other ones below that line are going to make it work. We good? We got one more. I told you this was going to be easy. Everybody's okay with that, right? Really, the only thing different is the fact of the shading. All right, it's really not much more difficult. Say that? All right. Got it? Okay. All right, let's do one more. What have we been doing lately? Yeah, graphing, but like more specifically, what kind of things have we been graphing that's kind of new? Absolute value, okay? Absolute value, so that's what we're going to do now. And at least you don't have to get y by itself. They already write it with y by itself, so that was nice of them. So just looking at this graph right here, what is it basically going to look like? It's going to look like a what? The V, right? But we're going to shift it, right? We're going to shift it where? 2 down. 2 to the right, okay? 2 to the right and 1 up, or up 1. I should have said to the right 2. But we're going to go up 1. To the right 2 and up 1, okay? And then what's the slope of it going to be? Well, one part's going to be 1. The other part's going to be -1, right? Because it doesn't just have one slope. So 2 to the right, right there, up 1, boom. So the vertex of that is going to be at 1. And what do? We just go up 1, over 1, up 1, right? To make our regular graph. Yeah, they are going to be dotted. All right, so I'm just putting a bunch of points in here so I kind of know how I'm going to graph. Everybody with me on that? So it's 2 to the right, 1, 2, and up 1. And then to find the slope of it, right? We haven't changed the slope of it at all. That's probably for another chapter. But now we can just do dotted. Why is it dotted? Yeah, because it doesn't have the or equal. Okay, so it can't be equal to the points on this line. All right, it's only what? Greater than. So where do you think the greater than on this one is? We can put arrows as well. Where's the greater? Is this greater out here? Is it greater here? Is it in here? Is it out here? Where are we shading? In the middle? Yeah, in the V. That's a good way to say it. Okay, inside the V. That's greater than. What if you didn't know? Well, pick a point. Let's pick 0, 0 again. All right? So let's put it in here and see if it works. 0. Let's see if it's greater than, what's that, 0 minus 2? Let's just write it in there so we know where we're getting this from. Is 0 bigger than this? What's this going to be? It's going to be a 2 plus 1 is what? Is 0 bigger than 3? No, it's not. So are we going to graph outside of this V? No. So we're not going to graph anywhere on here. Where are we going to graph? Inside the V. All right, so this is where we're going to graph. You okay with that? Yeah, easy. I told you it'd be easy. I wasn't lying. This is one time I said it was easy and I wasn't kidding. That's it. That's our lesson. Easiest lesson all year, isn't it? All right, let me put the homework. It's on the lesson plan. I gave you lesson plan, did I? Okay. So it's section 2.6, 90 and 91 pages, and 9 to 25. And I only gave you the odds. I considered giving you all of them. But it is graphing. It takes a little bit of time to graph. So they'll probably include all kinds of different graphs that we've learned how to do so far this year. All right, but it's going to be inequalities this time. All right, make sure if you don't put a dotted line and it was supposed to be a dotted line on a quiz or a test, that's enough to get it wrong. Everybody understand that, right? And obviously the shading, okay? If you don't shade it at all or you shade it in the wrong place, that's enough to get it wrong. The shape of the lines have to be correct. So there's a lot of things you got to consider when you're graphing these, not just how the line slants anymore. Back when you first did graphing, that's the only thing you had to worry about. But now you got to think about some other things. Yeah, it was easy. All right, so get that done. 9 to 25, just the odds. Just the odds.
Do we have time to do it now?
Not much. You only got 5 minutes, but okay. All right, have it done, though, for tomorrow, please.